So let's take a look at how to set up all of your fail-safe settings. And what's really nice about the LT500 is you can set all of your inputs and outputs independently. So let's start, as we always do, with a really quick setup. And as you know, with the LT500 and our quick start wizards, really quick to step through and pick all your options. And I'm just going to do the standard stuff here, default settings, just to get all of our configuration up and running. And we've basically just set everything up here. And I mean, I'm just on the simulator, so I can put any value I want to in here. So we're all set up. And if you want to set up your fail-safe settings, we're going to go into the setup menu, and under sensor, we're going to scroll down to our fail-safe diagnostics. So select fail-safe diagnostics. These are all the things, and let's go right to the top of the list here. Typically, loss of echo is the only thing we provide as a default. These are all the different diagnostics that you can select and customize for your specific application that will create a fail-safe condition. So anytime sensor not found, or temperature sensor malfunction, or low level cutoff, or filling too quickly, you can choose any of these and then save them. Submergence, anything that you would like to go into a fail-safe, you can either turn on or turn off. So typically with loss of echo, that would be a good one. But like I said, any of these you can set. Okay, and obviously it's quite an extensive list. Once you're done there, save your settings. And that basically says anytime those diagnostics turn on, we're going to go into a fail-safe. So from there, we can go back out and we'll take a look. And let's start, say, with our milliamp output. So under the setup inputs and outputs menu, our current output 1, and we only set up one measurement point. You can do this for both points. We're going to go down now and we're going to select the failsafe behavior. So here are all the options we have when the device goes into failsafe. We can go to our lower fault current, our upper fault current, the last reliable value. So that's the last good value. The current value. The difference there is we could have an uncertain state. So to give an example, any process value alarms are going to put us into an uncertain state, such as submergence detection or spill condition. That would put us into a submergence state, an uncertain state. So that is what current value will hold versus last reliable or good value is before we went into a uncertain or bad state. So just the difference there, and then a specific value that you would like to set. And again, this is on the milliamp output. So let's leave it at the lower fault current. That's fine for an option, so we're good there. We can then take a look at each individual relay, and I didn't set any of the relays. We'll just set something specific in here. Let's say under alarms and diagnostics. And any sensor diagnostics that we have. So let's say when a sensor is not found on this particular relay, we're going to have an alarm. And this could be for any function, could be pump control, alarms, basic control, whatever. And then again, if we go down to fail-safe behavior, we have some options here. So either disabled, hold the last state. So as the device goes into fail-safe, hold whatever state that is, whether it's on or off, turn on the relay or turn off the relay. So again, when we enter a fail-safe, what we would like to do. And in this particular case, let's say we want to hold whatever the last state was before we can investigate. And you can do that on all of your relays independently. So let's say relay 1 and 2 are for pump control, and we want to make sure they turn on in a failsafe or turn off. Again, it's totally customizable. Let's say relay 3 and 4 are alarms, and we don't need to worry about a failsafe state there. And then relay 5 and 6 are like a time of day or a flow sampler, whatever. we can set independent fail-safe characteristics for each of those, so that it is not just kind of a one broad brushstroke. We can be a little bit more discrete there. Okay, so that's your milliamp output and your relays. We can do the same thing with the totalizers. So all 4 independent totalizers. Again, we didn't set up anything here. I'm just going to select a PV that we can monitor. And again, we can select the fail-safe behavior. We can either stop totalizing, or we can continue based on the latest good value. So if we went into a fail-safe at 100 liters per minute, we will continue to totalize at 100 liters per minute. Again, each totalizer can be specifically set based on your application needs. So that's all of the failsafe. Again, all of your settings for what turns failsafe on, all underneath your sensor, all of your totalizer settings in the totalizer menu, and then your milliamp outputs and your relay outputs, all under the setup menu, inputs and outputs. And that's kind of how you can manage all of your failsafe settings. When we come back to our screen, we can take a look here. I can set the device into a bad status, and we can see that the measurement will stop and we will get the dash dash dash. So that is an indication that we are now in a bad measuring status. So for example, we went into a loss of echo after the timer expires. This is what you would expect to see on your screen. So if we go into a good state again, or an uncertain state, you will see the measurement value here. One other quick thing to take a look at. So again, if we go into the maintenance and diagnostics menu under monitoring, we can actually see what our inputs and outputs are doing. So you can look at the relays, the milliamp output. So right now we're outputting 12.37 milliamps. If I change my reading, then I can change my milliamp output. As you recall, we had this set to fail-safe low. So if I now enter a bad status, we're going to see that milliamp jump down to just below 4 milliamps, as is the Namur spec. And then if I go back into good reading again, we'll see that come back up to whatever we had it set as. And again, I can change my measurement value and adjust that milliamp setting. So just a quick overview of what we can do as far as fail-safe setting and how custom and flexible it is, and what you can expect the device to do as you go in and out of a fail-safe or a bad status measurement.